Hi, everyone. Oh, sorry. Okay, hi, everyone. So we are going to get rolling on 421. We'll try to wrap up at least the lecture two slides and then maybe get started on the signal warrant slide. And before we get to that, let's go to here. And I wanted to talk a few things. I know we scheduled our test for October 19th, but we would have Kittleson and Associates being on campus that day, and they want to talk about a little bit about, sort of intersection design and roundabout design and all of that. And I know they are the company that sort of pretty much wrote the roundabout guide in a lot of ways. So we'd love to have them sort of come out and talk about some real world projects. So what we'll do is like we'll move this test on the 19th to the following Tuesday. So I know it's going to make it all of our tests sort of closely bunched together, but that's okay, I think. So what we'll do is like we'll make our first test to be on 24th rather than the 19th. Okay. So just make sure that you make a note of that. 24th, and I'll just say here, I'll just say changed from 19th so that you're not shocked or anything when you look at it. So just want to make sure that we are aware of that. So our first test is now on 24th, and we'll have Kittleson come out and talk about some of the real world projects on the 19th. Okay. So that's one thing I wanted to announce. And let's see. The next thing is we were talking about sort of traffic engineering studies real quick. I did mention that sometimes on freeways, we'll do the peak hour factor calculation based on 5-minute peak hour flow. So how would you approach this problem? We're not going to solve it exactly, but let's think about how you solve this problem, right? If you want to derive the peak hour factor, so your goal is to derive the peak hour factor. So I want to go ahead and share my screen. So if you want to go ahead and derive your peak hour factor, how would you approach this problem? So the way you'll approach it is okay. So first, you need to find, like on all of these problems, first you have to find the peak hour. And peak hour would be a 60-minute period where maximum flow happens or maximum volume happens. And to that end, you'll start adding up from 3:30 all the way up to, so this is only 12 observations. So this is actually peak hour data. So now if this was longer data set, if this had more data points, then you would be adding those and finding out a consecutive 12 observations in this case, because these are all 5 minutes. In a 15-minute observation, you'll find consecutive 4 observations, and you'll add them up and find the peak hour. In this case, it's pretty clear that it's because it's only measuring from 4 to 5 o'clock. That is your peak hour. You know that. Now, you'll add up all these volumes, right? So that'll give you peak hour volume will be, so PHV will be sum everything up. And then for PHF, or so for peak 15-minute rate of flow, or peak not 15-minute, now this time it will be peak 5-minute, right? Because 5-minute measures, rate of flow would be what? Which number would that be based on in this chart? What number would it be based on for this chart? It'll be based on this 480, right? Because that's the highest number that you see here on this chart. So your peak 15-minute rate of flow will be based on 480. So it'll be 480 times what? 12, right? Because 5 minutes, 12 times 5 is 60. That gets you to 1 hour, because rate of flow always has to be per hour. So you may do 480 times 12, whatever that gives you. And then when you're deriving PHF, peak hour factor, it'll be sum of the total volume divided by 480 times 12. Right? So you could derive that using 4-hour data, 5-minute data as well. Okay. But if you had longer data, always, like you have in your homework problem, I think, you always have to figure out what your peak hour is first by looking at and finding out 4 consecutive 15-minute periods to make sure that you have the peak hour first, and then rely on that peak hour to derive your peak hour factor and everything. You can't go outside of that peak hour window even though there might be some other observations that might be higher numbers, you have to be within that peak hour window. Does that make sense? Yes, please.
So if it's like 4:15, you do it like 30 minutes like that. I'll just like for the sum.
Yeah, so for the sum,
Not just like the hours. You do it like
that's a good question. So what we can do is, I think to answer that question, I think our best approach might be just to look at it, look at a homework problem and see what we are dealing with here. Okay, so I think that problem does have that issue. So let's go back and I want to see problem set 1. Probably. Okay, so let's look at this one. This one, yeah, so this one, right? So your question is, how do we approach this? So what I'll do is for this problem is that I would add these 4, right? I'll add these 4. I'll note what that number turns out to be here, right? And then I'll drop this 67, add this 103, right? And so next time I'll sum these 4. Okay, and next step so you can do it more easily in Excel, for example, right? You could just do rolling sum by starting the sum here and then dragging down that formula, and that will automatically do that for you. And then I'll drop this 76 and I'll add that 135, right? So every time I'll just be adding 4 consecutive observations, and then whichever gives me that maximum, that will be my peak hour. And then when I'm trying to derive my peak hour factor, let's say in this example, I'm pretty sure in this problem, it will be this 4 would be what peak hour would be, right? So this is what the peak hour would be from 5 to 6 o'clock, but it doesn't always have to be at full hours. It could have been 4:45 to 5:45 as well, right? It could be any time period, starting any time, but it just has to be 4 consecutive ones. Now, for peak hour factor, then I'll rely on this 135 because that's the highest number within the 15-minute, within the peak hour period, right? That's the peak 15-minute period. So I'll rely on this one, this number right here. Now, one thing to note is that let's say, there was one other observation somewhere along the way that was like 136, right? Higher than 135. I wouldn't go outside of that peak hour window. I would still want to be, because the peak 15-minute rate of flow has to occur within that peak hour. You have to find that number that's highest within that peak hour. So make sure that you're doing that, right? So that's pretty important to note that, you are always going to, even if there might be one observation that's higher than that, you have to first determine the peak hour and then play within those peak hours is what you need to do. Pretty important, okay? When you're doing peak hour factor. Make sense? So even if there was a 136 anywhere else, I wouldn't worry about that 136, 140, whatever, unless that pushed that 15-minute into a peak hour. Okay, unless that was part of the peak hour, I'll worry about it. If not, then I'll forget about it. Okay. Does that answer your question? Yeah, perfect. Sometimes it's just easier to look at that. So we were dealing with this here. So we got so now last one, I want to talk a little bit about the pedestrian studies, and obviously, so this is 1990s, right? So, and why 1990? That's pretty interesting, right? It's basically the legislation that was passed. So in 1991, the legislation called ISTEA, ISTEA, was passed. And that was the first legislation, transportation legislation at the federal level that actually provided some funding for bicyclists, for pedestrians as well. And so that's basically what we're talking about here, is that since 1990s nowadays, and today even more so than before, now we have more money to build these sort of complete street infrastructure than we used to have. So you're more likely to see this type of infrastructure nowadays than you would see before. So So these pedestrian studies that used to be fairly uncommon now have become pretty common because we want to find out how many pedestrians are there. And then more importantly, not only do we want to know how many pedestrians are there, but we also want to look at, is there land use conducive to having more pedestrians, right? So if you are talking about a location near a school, I mean, a university campus, near a school, near a park, near an important shopping district or whatever, then you want to, our downtown areas where you maybe don't have pedestrians right now because you have not built the infrastructure for them. So everybody just drives. But nowadays we are relying on pedestrian studies, but even more than pedestrian studies, we want to look at the land use and see if that's more conducive to having more pedestrians in that area. So that's fairly important. So since the 1990s, we're now recognizing automobile, transit, pedestrian, and bicyclists. So studies relevant to those have become more important than they used to be. Yes, please.
Like a lot of times I think a lot of people think like there's a project to add bicycles to oh, but I don't like doing it. I don't like. How do you feel like? What have you seen as far as what's the add pedestrian and cyclist facilities? How do you see
There is actually a law. So the question is like, what about the induced demand for travel by bicyclists by adding infrastructures? There is actually significant number of literature out there that if you provide bicycle infrastructure, that adds to bicycle volume. So there is more demand that comes in because of bicycle. I think we are seeing that right now in SLO County and in specifically in the city of San Luis Obispo, since the city has started adding. I think their plan is good, like it's workable, it's sort of economically a little bit more efficient, is that whenever, so they've aligned their bike lane and then sort of buffering of the bike lanes that already exist, they've aligned those with their paving projects. So they're starting to see more bicyclists using those facilities. Now, sort of flip side of that is that bicyclists start using that, but they are not, because their paving timeline or paving plan where they want to do repaving and stuff like that, that doesn't quite align with where the pedestrians and the bicyclists really want to be, right? So for example, they're paving Orchard Road right now, and they're adding buffered bike lane on Orchard Road, but potentially there is more of a need for that on Higuera Street, right? So nowadays, they're actually, so the next step I was talking to the city folks yesterday even, the city is about to go through a paving project on Higuera Street, which is basically pretty significant need, all the way from where downtown is, like on South Street, where sort of downtown heads from South Street, all the way up to LOVR. They're going to repave it. That's the next repaving project, and they're going to add a lot of significant buffered bike lane, protected bike lane on that route. So I think that's going to be pretty interesting, pretty exciting project. And then one more thing that happens in terms of induced demand, they may not get like a lot of new demand that comes in. Yes, obviously we want the new demand, and some of that does happen. But a lot of time, bicyclists start to use that road quite a bit often, right? And that actually is good, because even though the aggregate demand for bicyclists don't increase, the bicyclists shift to the safer infrastructure, and consequently cars shift to more sort of highways and things like that. So one thing that you have to be careful about here, when that sort of demand shift is happening, is that when you're trying to analyze these before and after effects, you can't just look at that one street. For that before and after study, you have to look at, okay, what happened to the other competing routes as well, because you don't want to have sort of those streets to be increasing in crashes, because now everybody who's driving is going through there, and there are some bicyclists that there is no way they can change their route, are now stuck riding on that more dangerous route, right? So you have to be a little bit careful when you're doing before and after analysis. But to answer your question, short answer is yes, there are studies that have documented induced demand for bicyclists. I think bicyclist demands are up, and there is very, very interesting study I noticed very recently that came out, and they looked at which are the cities that have seen most increase in bicyclist route, and number 3, or not bicyclist route, but bicyclist demand, like how many trips are being made with bicyclists. And I think they used some online database like street light data, And what they found was Bakersfield, of all places in the state, right? Bakersfield was the one that saw, I think they were like number 3 in the country among the top 100 cities in the country, like with top 100 by population, like metro areas in the country. Bakersfield area was number 3. And in that, they saw 70% increase from 2019 to 2022 in bicycle, which is great, right? And they are doing some of that stuff. And now on the flip side of that was Fresno was the 100th in terms of those 100 metropolitan area, and they had like a 10% decrease in number of people biking. Now, I haven't looked at the data carefully, but I'm aware of that, the fact that Bakersfield is doing a lot in terms of their bicycle infrastructure. And I know Fresno is not necessarily, I haven't heard about Fresno. So my thinking is that maybe they're doing okay. They're probably doing some things that maybe they're not doing so great. And I haven't dwelt into the data if there is a quirk of the data. But that again gives me an indication is that if you actually start to build infrastructure, which I know Bakersfield is doing to a lot of extent, that MPO, they're putting in a lot of money in that, and they're seeing increases. And, to me, the way I know of Fresno and Bakersfield, to me, they should be, like, if you just look at the raw factors of the weather, of like the population, the demographics, they should be pretty comparable, right? I mean, just off the top of my head, I can't think of any reason why those two places would be significantly different. They're part of the Central Valley, pretty flat. The weather is pretty similar, the Central Valley weather. There's a lot of agriculture in both places. And obviously they're, Fresno and Bakersfield are both sort of gaining a little bit of population because the coast area is like, getting priced out for a lot of people. So they're seeing some increase from coastal California. So that was interesting to me is like how those things differ from each other, right? So yeah, I would say, so I know we took it in a long-winded direction, but yeah, so if you add bicycle infrastructure, I think you do see some increases. And sometimes you have to collect that data and that's what we're talking about, like, how do we conduct sort of pedestrian studies and document those things. Yes, please, Matt. Yeah, so I don't want to so let's say, I mean, my opinion in general on like most of the things that city is doing, I think they're good steps. They could be better, right? So I think that sort of is my blanket opinion on a lot of things that happen. Broad Street, do you have any specific concerns about Broad Street that you want to? I think that's part of just the funding issue, right? Sometimes they have funding to do projects in piecemeal basis, and it can be pretty irritating, like, as an end user to kind of like, yeah, you're just dumping me out of nowhere, right? Like, you're giving me infrastructure for a little while, but I can't rely on that because it doesn't continue, it doesn't persist, it doesn't take me to my end destination. So I think that remains a concern, is that, those things are piecemeal. Those are like, for part of the way, they are protected, part of the way they're not. But again, they are working under, and I don't know specifically what program that they used for funding it and all of that, but usually that's the main, upshot of like, why that happens is, they just ran out of funding. Did you have some thoughts on it?
Yeah, on that, like how I think that's fair because I don't know how effective my things work with like home. What's in your parking? Are you taking away that?
Yeah, people don't give up parking, right? That's one thing that we know, like, even if, parking is, I mean, I shouldn't say parking, right? Anything that people have, if you have to take that away, it's a challenge, right? Anytime, and that sort of works up and down the chain, right? You could talk about smallest of things or the biggest of things. Once people get used to something, once people have something, it would always be hard to take that away. So yeah, we run into that, like, taking away parking always becomes a big issue. And homes and businesses. But one thing that I would say is that if you are able to somehow communicate the benefits of that, there is potential for improvement, right? Because I was doing a pedestrian sort of walk tour, road safety audit yesterday in Santa Margarita with Slowcog a little bit. And what we learned from people of Santa Margarita, it's a rural community, that there is similar demands and that their businesses have it. They would love to have slower speeds and maybe even less parking if they can, if they can sort of get that safer infrastructure, because then realize that the more businesses will stop at their location and so forth. So it's always, it was kind of eye-opening in some ways for me, because I would always think that, maybe the rural communities want more parking and they don't care about slowing down the people, but they do, because once they see the cut through traffic coming into their town, they do want them slowing down. So there is some, and what people in the city sometimes want is also the people in the rural area sometimes want. In fact, you could find people in the city that don't want to take away parking, that don't want slower speeds in some ways, and that sometimes gets flipped around. And so it was interesting that what we saw yesterday. So yeah, but again, a lot of times it's parking, it's taking away right away, and a lot of different challenges that they're facing. So you're talking about, okay, so you're talking about Broad Street in so basically the other side of the freeway, not the downtown side of the freeway. But yeah, I think that area, that whole area could use some pedestrianized areas, but again, kind of hard to achieve because of that right of way issue. All right, so let's talk a little bit about the pedestrian issues. So one thing is that pedestrian fatalities, 1.2 million traffic-related fatalities and 50 million injuries worldwide. Almost half of them involve pedestrians, because again, pedestrians are recognized as sort of vulnerable road users, right? If you can't go very fast, you are exposed. If you're on the road, you're exposed. And some of that issue is also driven by, and as we saw, a lot of times, it's a nighttime issue related to road lighting. So pedestrian safety, really, really major concern. And I think the way our housing policies are and a lot of that, we have the, homeless population increasing. I think this is going to become, this is becoming a very big challenge. So I think we have to provide safer infrastructure. Otherwise, we'll keep seeing that increase in deaths. Yes.
Half of the fatalities and injuries, or both?
Yeah. So I think this is the deaths. I think this is yeah. So I think this is related to the deaths. Because pedestrians are just way more likely to die if they get involved in a collision with a motor vehicle, right? So that's just the way it is. So this is specifically because you could get injured on a car as well, but your chance of surviving that collision are just way more than they used to be, even, right? So as an automobile occupant, you're way more likely to survive nowadays than you used to be. So yeah, this is related to fatalities. And this is so where we're trying to build this type of infrastructure nowadays, and this is on the left, you see a very, very automobile related automobile focused infrastructure, but on the right we're seeing, and again, this may not be perfectly safe. The width of the bike lane may not be enough. The bike lane is not really buffered, and who's to say people are not going to just park here if they need to, and then they do, and can get pretty irritating. But again, even though this is not ideal, it's probably better than this, right? So you're not dealing with shadows, you're not dealing with sort of these two-way left turn lanes where you can enter the driveway at any time and all of that. And this is way more protected, because a lot of fatalities do happen when people are making left turn and not looking at in the direction of where the pedestrians might be coming from. And again, so this is again before and after, same location. You sort of pedestrianizing it, providing bicycle lane, providing these buffers, providing bulb outs for people to cross so that they're not having to cross as much width, and all of that. Again, you require data, not just sort of the data that you already have pedestrians using it, because that sometimes is not convincing enough, but potential for pedestrian use, taking into consideration the stakeholders, the businesses, and all of that. So one of the studies that we always have to kind of think about is the walking speeds, because walking speeds are very important for traffic signal timing. They are very important for not just signal timing, but like making the case for pedestrian bulb outs, and bulb outs are basically a mechanism for reducing the width that you have to cross, and it makes you more visible, right? So they basically bulb outs are just sort of extending the curb a little bit where you have the pedestrian crossing. So to be able to demonstrate that, you need to conduct pedestrian walking studies. They're affected by so many factors. Volume of pedestrians, if it's a crowded area, then you'll have slow movement of pedestrians, age, gender, physical fitness, density of oncoming pedestrians, what's happening on the other side of the road, if there is a grade involved, width of crossing, distance of oncoming vehicle, speed of oncoming vehicle, weather conditions. If you have inclement weather, then maybe pedestrians won't be walking as slow. They're walking in an umbrella or something. So a lot of different factors affect it. And then, but we sort of measure the speed, pretty much in the same way. But we typically do it based on distances, right? So we try to measure with a stopwatch some randomly selected pedestrians and try to establish the data. Now, you won't, if you try to sort of get this information would be pretty hard to get just by observing pedestrians, right? Because you won't know the age of information, right? So there's a table that you have on the side here that requires a much more extensive, intrusive survey of, finding the pedestrian age and then measuring their walking speed. So kind of, so that's a more of a, and then this is what they've done is they've basically taken data on a lot of different pedestrians, right? So they've basically, so that's how they're getting those 50th percentile walking speed. So this data is way more intrusive, result of a much more detailed study, versus a lot of time you would be just interested in what's happening at an intersection. So you just kind of pick out random pedestrians and you try to get a sense of, so the way you pick out random pedestrians is not like, you don't pick out always the fast movers or the slow movers. You just say, okay, I'm just going to pick out every fifth pedestrian that crosses this road. And again, you have to be careful about that because the faster moving pedestrians would be reaching that point pretty quickly. So you have to be careful about how you're picking that out. And but this is not, there's no radar gun or anything involved here when you're doing pedestrian study. That has to be based on distances and stopwatches and all of that. So you kind of measure it that way. And 50 to 100 pedestrians is usually adequate. But again, the data that you see on the right is not coming out of a study like this. Okay, data that you're seeing on the right would be a much more detailed study where you study the age, and you collect a lot of data, and then based on that data for each age group, you're figuring out, the speeds. And it's funny to me, that 2-year-old, that the kids' walking speed is so different, and then the girls walk so much faster than the boys, and then sort of it kind of gets much more equal and balanced after that age. So it's funny because girls probably start walking a little bit sooner, I guess. So yeah, something to think about there. But this is, again, this data, way more detailed study than what you're seeing here. You won't need to do this kind of study all the time. Pedestrian walking speed, 3 to 6 feet per second. If you're running, you can get about 10 feet per second. And for the MUTCD, now here you use the 15th percentile because now you're looking at slowest walking pedestrians. So you design the crosswalk much more sort of conservatively. Now, this, and if you're wondering where this 15th percentile, 3.5 feet per second study comes into play, it's when you're talking about, if you look at a pedestrian walk signal, you might have seen the sign that says walk signal versus the flashing hand signal, right? So that flashing hand signal remains in place. Flashing hand tells me that don't start now, right? So that flashing hand signal timing is determined by 3.5 feet per second speed times, that you divide the 3.5 with the number based on the width of the sidewalk. So the width width of the crosswalk. So if you're crossing, let's say, a 30 feet sidewalk, a 30 feet crosswalk, you're crossing from one side to the other, 30 divided by 3.5 would be whatever, 8 seconds or whatever that is. That will be the indicator that will be flashing for flashing don't walk, so that you don't start at that time, and then you add some safety time on it, like an all red interval to it, and then you go from there. So 3.5 feet per walking speed is what typically used to determine how much time you'll have the flashing hand signal. And we'll talk about that later in the class when we actually do the signal timing stuff, but something to keep in mind where this data is typically used. Walking speed for physically impaired pedestrians, like again, this is something you might want to use near a hospital, for example, where average walking speed, a low number would be used. So something to keep in mind. Again, this is a data that will require you to kind of observe, and then if you're deriving some kind of an average, then in each of these categories, you're going to need enough data sample to get the average, right? So this is kind of way more detailed study, and those sometimes might be needed if you're talking about an old age home, if you're talking about a hospital, things of that nature, if you're trying to design a sidewalk in those types of location. And then pedestrian walking signs are used in response to all marked crosswalk with pedestrian crossing assemblies, pedestrians ahead, next 500 feet, next half a mile. I wonder, does anybody recall, do we have those on Santa Rosa? When you're approaching Santa Rosa from Cuesta College on there. Yeah, and then I wonder if there is some kind of indicator, but that's one area where there is some concern. Yeah, so there is a signal ahead sign. Yes, obviously that's there when you're approaching that from the fire station. But again, those areas with pedestrians is a significant concern. But again, that's a Caltrans controlled road. So, and that's another thing, right? So anytime we have pedestrians interacting with a Caltrans controlled road, that's where we see most sort of dangerous conditions for pedestrians, because obviously Caltrans doesn't want to slow down too many things, because the road sort of north of Highland Drive is more of a rural area. We need throughput there and all of that. But then once you come on this side, there's so many pedestrians, and there's a shopping area, that would become a shortest path to Cal Poly, and you must have seen people crossing, and dare I say, you might have crossed yourself. And again, to an extent, yeah, you can blame the people, but again, if there is a shortest straight line path, it's very hard for engineers to dissuade people from not using that path. So maybe that's where we come into like this forgiving areas and kind of figuring out what's the best way of providing infrastructure. Bridge is an option, pretty expensive option in a lot of ways. But again, maybe we need to figure out, how we slow things down. But if, people are still going to come in from Morro Bay to SLO from that route, and maybe, that's the one big challenge is, what's the balance there, and how do we take care of that? Safety, I think, to me, should trump everything, but that doesn't always work out that way. And that's why there is some studies that have, you start noticing that DOT controlled roads where you have pedestrians crossing, so there are not sort of freeways. So DOT controlled arterial streets are among the most dangerous roads in this country, because, there is that dilemma of like, when does the high speed capacity based analysis should end, and where safety should take priority. I think safety should take priority everywhere, but that doesn't quite happen. And we see the results of that in high fatality rates for pedestrians on specifically DOT controlled. California actually doesn't report that in their crash data, but some other states do report, like who maintains that road. And those states clearly, you could clearly see the pattern of pedestrian fatalities being high on those types of roads. So something interesting, and that's where these warnings can potentially come in handy. Not always, but I think maybe can focus, maybe the enforcement effort could focus on those specific areas, and so forth. So that's there. And then there could be other signs like alert turning drivers to yield to pedestrians, turning vehicle yield to pedestrians on both sides. Watch out for pedestrians. Maybe having some kind of a voice signal for pedestrians, all of that. And then there is this question of like no turn on red or no right turn on red, right? So that's another thing that we are looking at right now is, so when, at least our current warrant, like when we should provide turning vehicles to pedestrian sign, more than 100 vehicles per hour turning across a crosswalk during peak hour, and more than 50 pedestrians per hour using crosswalk during the same time, right? So one might argue, and then this is an or, so you could use either or, so that's good, I guess. But one could argue that this is, this is sort of reactive in a lot of ways, right? Like, you're telling that if you see 50 pedestrians crossing, then you provide that signage. But to me, signage is such a low cost thing that you should probably be, and again, you don't want to clutter the locations, but having, maybe you want more pedestrians in that area, right? Maybe there are locations where more pedestrians would have been there had you, provided more signage. So yeah, I think sometimes you have to look beyond these guidance to provide infrastructure, to provide signage for more active travel to take place than it does. But this is some of our current standards that exist, and again, they're based on collisions. 2 or more crashes in past 12 months, or 3 or more crashes in past 3 years, and then involve pedestrians entering vehicles in adjacent crosswalk. So something to think about. And then once you install it on one leg of the intersection, you can potentially install on all legs of the intersection to make sure that infrastructure, that signage is provided. There are different types of signage. You don't see these signage very often. You want to be consistent. The uniform traffic control devices, and these are, and there is actually evidence that, so this is just a funny slide here that you see, and moose and all of that. I don't know where that sign is, but you, and before and after. Anyhow, so these are like, but what we want from our signage is give a consistent message, don't confuse the drivers and road users. And then also, actually, there are studies that some of these signage that sometimes DOTs and the transportation management professionals will put out that are sort of cute in nature, they don't work very well, actually. They don't do what they're supposed to do. For example, in so there was a particular stretch of highway in Texas where they started posting signs like, these cute signs about click it or ticket, and not exactly that sign, but there were like some funny signs, and they were good. Like, I would say that they were sort of funny and kind of creative signs. But when they actually look at the data on collisions, the collisions actually went up downstream of those signs, because those signs actually maybe some ways distract drivers, and then they control for a lot of things. So they didn't just say, okay, they looked at similar locations without the signage, and they looked like, they analyzed the data pretty sophisticated way, and not just sort of random, naive before and after study. They looked at it. So it's very, you have to be careful about the messaging that you're providing to the road users, because even those messages that DOTs will put out, they're not very effective from a safety perspective. So traffic signs, main part of the traffic control devices, promote highway safety and efficiency through orderly movement, notify users of regulations, provide warnings, and give guidance, use word, symbols, and arrows to convey messages, can only have messages related to traffic control. So this is kind of, I think, important, is that you don't want to have so confusing, you can't have advertisement, DOT can't make money by putting, advertising on those signs and things like that. So there are different types of signs. There are 3 different types: regulatory, warning, and guide signs. So those are sort of guide signs are your wayfinding type signs. Warning signs are notice of situations that might not be readily apparent, like, a ramp on the left, for example. So you want to warn drivers about that. And then there are, regulatory signs that are traffic laws that are enforceable: stop sign, yield sign, speed limits on the white sign. So those are sort of your enforceable signs. So among these, only the regulatory signs are directly enforceable, although you could enforce the signs like by saying that you were not, sort of reckless driving type ticket, you could still get either way. But directly enforceable sign are these regulatory signs. Sign codes. So these are different sign codes that provide, like, again, from MUTCD, uh, standard highway sign, and California has its own. So this is federal guidance, as I was telling you. And then all those signs have to have this much, this is sort of the specific dimension. And those signs are huge. And I don't know if you've seen a traffic signal, pole up close like this, and I have, and it's, I knew the dimensions, like, I had a certain idea about what those dimensions are, but, it was still a little bit jarring when you actually see it in front of you. It's pretty much as tall as a human being, right? So they're not quite 5 to 6 feet, but they're pretty close. So it's pretty interesting to see them up close. So yeah, these are, but again, you don't have to remember these dimensions. You don't have to worry about these dimensions. But what you need to kind of take away from this slide is that there are standards that we have to follow before we can go out and put any kind of sign. So that those signs have to have certain way of, like, font size has to be a certain way. The signs dimensions have to be in a certain way. There are places where the signs can be put in. There should be certain level of visibility on those signs. The paint can't be faded and all of that. And if that happens and then you have a collision there, the agency could potentially get sued that if the sign was not fully visible and all of that. And that's why, these things are becoming, these things are important and should always be accounted for. Again, warning signs, brake sizes and all of that has to be there. And this is, again, size of the stop sign, the pole, all of that, the speed limit sign, the yield sign. If the speed limit is more than 30 miles per hour, then the sign has to be bigger. The speed limit sign, and again, it all depends on what type of information and how critical that information is that you're trying to convey. And again, I'm not interested in you knowing about these specific dimensions, but I'm trying to put these slides in there for you to kind of know that those regulations exist, and there is a way why we do certain way that we do. So we have to do the things the right way, and provide signage with a certain sign, certain fonts, and all of that. Same thing applies for pavement marking. Again, you can't. You have to have it, so this is kind of weird, like, but and then when you're reading the text, like, for example, on a pavement sign, it has to go in a certain way. It has to have, like, you should be able to read it moving forward. So there has to be in a certain order when you're providing pavement sign. So same rules apply to the pavement sign. It's the same kind of pavement marking. The same types of rules apply, and they're based on how human mind sort of reacts to certain situations and so forth. Yes.
That bike lane that's on the wall, I don't have that.
Yeah, I mean, these things do happen, and but you have to have that code. But maybe there is, but again, you don't know exactly what's going on behind. Yes.
It's not the US though, right?
This should be US, I think. Don't you think it's the right? I think it's on the right. Traffic is moving on the right side, right?
They're in US. Like that would be about like
What makes you think it's not US?
oh, the curb is down. I couldn't see that.
Oh, the curb, like where? The
Yellow.
no, these
Like-
yellow lines.
Yeah.
Oh, separating the bike lane with that one. I'm not sure of that. I think this might still be US because this might be. Yeah, that's a good point. Yeah, I'm not. Yeah, I'll have to look into that. Yeah, where this picture is coming from, and I'll have to consult. But yeah, that's a good point. Usually, if you have the bike traffic going in the same direction, you should have, unless it's a facility that sort of serves the bicycle on both sides, which I don't think it does here. So that might be. Yeah, so this yellow line would indicate sort of end of the right of way. I'm not right of way, end of the motor vehicle, side of like where the cars can move. So yeah, that's a good point. I'll have to look into it. Yeah, it's a good point. Like, we typically don't end our roads with like this yellow sign unless it's like a freeway, and you're basically separating out the shoulder. So this is obviously not the case here because you have these bike lanes. Pavement markings apply to road surface to provide guidance and information. pavement, curb markers, delineators, colored pavements, channelizing devices. So these are all sort of examples of pavement marking. And use alone and to supplement TCDs. Can you guess what TCD stands for? Traffic control devices, TCDs, MUTCD, all of that. And then, so this is sort of like, you know, they were providing centerline pavement marking equipment there from a long time ago. But again, you're conveying regulations, guidance, and warning. So you will see pavement marking for use of all sorts of purposes. You know, it could be, so if you look at the pavement marking, for example, this one right here, I mean, obviously this is a wrong one, but you know, stop sign, the stop line actually is it's a regulatory sign that you're supposed to obey. And then let's see, and you can see guidance, like, you know, whether which route you're taking from that lane. So it's a 550 north, whatever it is. And then you could use for warnings as well. So just kind of like, you know, sometimes it will be chevrons and things like that. So you could use it for, the pavement markings could be used for any of these three purposes, right? Regulations, guidance, and warning. And those are three good categories. So anytime you're looking at MUTCD, you're looking at any kind of guidance, they could fall within these three categories. The pavement marking must be visible in all conditions. And that's not always the case, and that could sometimes lead to problems. Retroreflective on freeways, so that when the light comes in, your car's headlight, they reflect back. Night visibility, unless there is, you know, unless you have roadway lighting, which we don't a lot of times. So that has to be there. So these pavement marking has to be visible. And again, part of the reason why they recommend you stop and not drive is, like, you know, sometimes the inclement weather might make these pavement markings completely invisible, and that's a problem sometimes. And the conditions. So that's one big reason why they advise you to not drive, because sometimes you can't see where the lane ends or start and all of that. So this is again some examples of pavement marking denoting the two-way left turn lane. You know, this is sort of the buffered bike lane, then there is this parking, and and again, these pavement marking also have some specifications on sizes. Don't worry about the specific sizes, but then, you know, they are like, you know, different DOTs have different specifications, and you have to sort of follow those specifications, and you have to make sure that those are fit to certain specifications. Again, those specific, I'm not worried about specific ideas, but you have to know and consult MUTCD or the California MUTCD when you decide to have pavement markings there. The last one is sort of in the regulatory sign, speed limits, maximum allowable speed for section of roadway established by law, typically posted on a sign. Speed limits are often determined based on 85th percentile speed, typically a few miles per hour less than the design speed. Now, in California, there are some interesting things that are happening with regards to speed limit with the law that was just passed last year. A lot of communities have not quite adjusted their speed limit based on that, but it does provide some flexibility to deviate from the 85th percentile rule and still be able to enforce that speed limit. So here was the question, right? So this is all about the freeways, but so I'm gonna AB 45. So it's called the Assembly Bill 45, I believe, which established that the communities, if they think that they're like, you know, this is their central business district, they have more flexibility in setting the speed limit to be lower than the 85th percentile and still be able to enforce that limit. So before, what the problem was that if your speed limit was, let's say, lower than the 85th percentile speed limit, as a community, you could not ask the police officer or the law enforcement to go out and issue tickets to people who are going above the speed limit, because your speed survey tells them, and this was required by law, that you have to have the survey on file. And if you had the survey on file and that said that your 85th percentile speed is higher than the speed limit, then you could not enforce that speed limit. In fact, you were forced to raise the speed limit to match that number. Now, AB 45 gives more communities this flexibility to establish a lower speed limit. If you're talking about a central business district and you expect pedestrians and vulnerable road users in that location, now you're allowed to do that. Now, the challenge, I think, is that enforcement is a very expensive thing, right? Enforcing the laws with a cop is very, very expensive. It's yes.
What about speed cameras?
Speed cameras are great. I think they would be more fair in a lot of ways. But again, it's hard to take away something that people have. And I think people feel that they have the right to speed in a lot of ways. An automatic speed camera would be a way that, you're sort of going to be taking away that right in a lot of ways. So I think I would argue, if, especially in sort of these urban areas and university campuses, those types of places, we should probably be putting in the automated speed enforcement, particularly in the areas where, I was talking to you earlier about these DOT maintained state highways and where you see pedestrian activity, right? In those areas in particular, I think automated speed enforcement could be really wonderful, could do a lot of good things, could really bring fatalities down. I really believe that because, and again, if you look at chances of collision being fatal at 55 miles per hour versus 35 miles per hour or 45 miles per hour, they just increase in a pretty significant way as you increase the speed at that level. So I think automated speed enforcement on Santa Rosa, I think would definitely be very, very helpful. But again, you have to muster the political will. I think if anywhere we could muster it, we should be able to muster it here. But even here, it's very difficult, right? So yeah, those are effective. I think one problem with that is that there is a lot of goodwill that we lost when these red light cameras enforcement was done. And a lot of times, communities and companies who were sort of operating those cameras for red light running. And there is a lot of examples of that. I don't know specifically from California, but there are a lot of examples where those cameras were used for sort of as a revenue generation for the communities, for the agencies, and also for the companies. And that's poisoned the well a little bit for the automated enforcement. And I think we need to kind of somehow convince the public again that, maybe on a pilot basis, let's do this. And I think once we see the safety impacts, once we can show that the collisions go down, I think we could probably make some headway there. So something that like that would be really, really helpful. But one thing I would say is that if you can enforce using automated enforcement, enforcement is a very expensive thing. And then there is some equity issues involved with enforcement as well, right? Who gets stopped and what type of drivers get stopped and all of that. So I think there is that question as well. So it's expensive from that angle too, because sometimes traffic stops could lead to bad outcomes just by themselves. They harm the police officers. They could harm the driver that they might be stopping because there might be some other issues going on there. So there are so enforcement could be expensive and problematic in a lot of ways. So if we can switch to automated enforcement, I think that will be really, really helpful. And the other thing is that just lowering speed limit by themselves might not do some things, right? So if maybe what we need to do is have the bulb outs, have the places that narrow the lane where the drivers start to feel like, okay, yeah, maybe we need to, really reduce our speeds, maybe give some visual cues that give an indication of how fast you're going. There are some visual cues based on human factors that they can determine how fast you're going and all of that. So yeah. So I think this 85th percentile speed law has changed a little bit in California, which is a great news. But again, you have to slow drivers down by design. So just by changing the law or just putting up a sign with lower speed limit is not by itself going to do things. You have to make sure that you're able to kind of slow people down by design. And you don't necessarily have to do that on the freeways. So I'm a big fan of lower speed limit, but maybe they have to kind of do that on those roads like Santa Rosa, for example, rather than trying to lower speed limits on freeways necessarily, right? So those are sort of nuanced discussions that we have to have with regards to speed limit and something to think about there. Yes, Max.
I just curious with Dr. Julian, like one thing that think about the presentation is making sure that Dr. Julian was way more, and I was on my way more than like 10 times.
Yeah, I think definitely a pedestrian, specifically for vulnerable road users, the question is like, what happens because of the electric vehicles that weigh more, and then in general, our vehicles have increased in weight. Even the ICE engine vehicles have increased in weight quite a bit. So I think we see that some of that in the fatality outcomes, specifically for vulnerable road users. I think those are going to be pretty bad outcomes. I think automobile occupants probably are going to be still okay, because I think we are improving the occupant safety quite a bit, right? Because the car companies are pretty sensitive to being lost, to the needs of their customers, right? Because those are the people who are buying the cars. So the car companies are very sensitive to keep them safe. So even if the weight increases, there might be marginal increase in the rate of fatality even for automobile occupants, but that I think would be dwarfed by the increase in fatality that might happen because of those higher weight for the vulnerable road users that are outside of the vehicle's protection area. So I think, definitely that's a big concern. Yeah, I would. So that has to be something we have to worry about, because of the battery, because we are demanding higher range from our vehicles, because we have this range and anxiety or whatever, and that's going to be an issue for us to kind of be contending with, and to be worried about that. Okay, so I'm a little bit worried about right now is I have a charger here. Does anybody have a USB-C charger, which I don't think I have? Okay, thank you. Yeah, if you have a USB-C charger, I would appreciate it. Looks like I haven't packed mine today. It's not charging.
Yeah.
Thank you. USB-C, right?
Yeah.
Perfect. Yeah, this should work. Hopefully. So, as we were keep talking about range anxiety, I have a warning on the battery. So, and some of these concerns, right? Like the speed limit concerns, we always wanted to not have the speed limit, but in 1974, Emergency Highway Energy Conservation Act, 55 miles per hour national speed limit. And there was no national speed limit per se, but what it was that your transportation funding could be withheld if you did not have 55 miles per hour. But again, there was a lot of political opposition to it. And then it increased to 60 to 65. And then we basically completely, states were given the complete authority to set speed limit in 1995. So it's all up to the DOT. And you see that when you cross the border over in Arizona, speed limits are a little bit higher than here. Texas, we have some roads that are 80, 85 miles an hour speed limit. So yeah, I mean, those things are there. Again, I don't know if freeway speed limits are necessarily the huge concern, because obviously our freeways are way over designed, and for the most part, our cars are much safer now. We provide a lot of buffers to our drivers, but I think the speeds are a bigger concern, where you have this mix of vulnerable road users and car users, and specifically areas where the drivers don't feel the need to slow down because the infrastructure is still like 12 feet wide lane, maybe 2 or 3 lanes, and all of that is happening. And that's where you're trying to slow people down. That's where speed is a very, very big concern. And then we have to kind of think about those quite a bit. And again, this is one important question there is, maximum speed limits, and you could see that there are some states that limit to 65. California is at 70, and then you see, in Texas you have even 80 and 85, small stretch of road there. And again, I'm not sure necessarily if that is a big issue. I mean, that could be, and they should be monitoring that fatality rates and all of that. And then we should always look out for if a safety problem is presenting itself. But I think our bigger problem in terms of safety is on those roads, especially state roads being street and roads combined, is a term that we use sometimes for those what's happening at Santa Rosa, on Santa Rosa between Foothill and Highland, for example, right? And you can sort of extend that idea over to even from Highland all the way up to, all the way up to when you get close to downtown, like Mill Street or something, on those areas, and there is a lot of roadway car traffic that interacts with pedestrians and bicyclist traffic. So that's why I think where speed limit is a bigger concern. Now, one speed limit question that's the question of research that you should be looking at is the states with car and truck differential speed limit. So these gray states are differential freeway speed limits. So whenever you're towing in California, the speed limit is only 55 miles an hour. So for all trucks, it's 55. At any place, you can't go faster than 55. And then some of these other states have no speed limits at all. So it's kind of interesting, and it doesn't always follow sort of political things. It's just, all different types of states are all different type of. It looks like the Western states are sort of more on the differential speed limit for trucks versus the others. So again, to what extent those are effective, I haven't seen a good sort of very good, well-designed research on it. So something for states to look at is it, what's working better, and what's would love to hear, like, if you guys have any thoughts on how would you design a study, a traffic engineering study that would look at this question on which one is better, the uniform speed limit or a differential speed limit. And differential speed limit could be implemented in a lot of different ways, but let's, for the sake of discussion, assume that you're implementing it like California. So anytime you're towing or you're a truck, you're always going to be at 55. How would you sort of evaluate which one of them is better? Why don't you think about that maybe, and maybe talk to your neighbor and see if you can come up with a study design that'll help you sort of think about that question a little bit more carefully. And again, we're not going to do that study, but I'm interested in what would be a well-designed study that will get at that answer. Which of these is better? So maybe think about that for a couple of minutes, and then maybe talk to your neighbor. If you have any questions, let me know. I'll be happy to sort of move the discussion along. But let's take a next couple of minutes to think about it, and then maybe next couple of minutes to talk up to your neighbor about it, and then let's come back as a class and discuss it a little bit more. Which is better in terms of truck speed limit, and that there are states that do it differently too. How would you think about whether or not differential speed limit would be better? Look at the map, see if there are some ideas from the map, maybe. I'm trying to figure out which of these states are, or which of these speed limit strategies is better. So how would you think about that? How do you approach that question? If somebody were to ask you to figure that question out. I'm just saying, like, yeah. So question from Nick is like, are we talking about rural versus urban? My question is, I'm sort of questioning the strategy. Like, let's say California does it, like anytime you're towing, you're going to be at 55 no matter what. You have to be at 55. Versus Arizona, for example, it looks like it doesn't have differential speed limit. It might still have it on certain segments, right? Like, maybe on a downhill, they limit, truck speed limit. But in general, they are a white state. Like they have, for the most part, they might have segmental variation, but no uniform law throughout the state that, yeah, truck speed would always be lower the speed limit would always be lower for trucks. So I'm interested in knowing about the policy. So it doesn't, no matter urban, rural, whatever, I'm just, so interstate system, like from a policy perspective, would uniform speed limit be better, or having a different speed limit for trucks would be better from a uniform policy perspective? And how would you approach figuring that question out? So if you have thoughts, maybe exchange it with your neighbor as well. I would be very interested in learning what you're thinking. Have some thoughts? Okay, anybody wants to take a crack at this? How would you figure which one is better? Let's go here first. Yeah.
Do a longitudinal study where, and a pilot program where you first study collision rates between large with towing vehicles and trucks, where you specifically look at collisions that are caused by high speed, such as rear ends.
Right.
And then you have pilot programs on certain segments where you remove the truck speed limit and have it as uniform, and then you compare the crash rates from that afterwards, and find that there's no difference, then under the pretense that having extra signs reduce the effectiveness of such signs, then the uniform speed limit will be better, but find that if it's like a 15% increase in collisions involving heavy vehicle speeds, then it just, I guess, proves the point.
Yeah, so I think that's one way of thinking about it, but that would require, in fact, that you have to have sort of a pilot program in place where we change the speed limit, and then you sort of do like a before and after. And in before and after, you always have to kind of think about, like, are you establishing the right counterfactual, and kind of having some control segments give you that counterfactual, like what would have happened had you not changed to a uniform limit. And I think that's one good way of dealing with that. Yes, back there.
Okay. At historical records of two very similar roads, one which has different forms of uniform, and
Right. So kind of look at similar roads. Now, similar roads would be, so one thing is, like, if you look at this map right here, yeah, maybe that could be interesting to think about, is that, maybe you look at these border segments of what's happening. So when you're saying existing roads, I think these state border segments are segments that are close to the state border, where you expect, like, sort of similar weather. The only difference being, but again, you'll have to kind of go a little bit, some number of miles on either direction, and kind of think about, what is the collision experience of one segment on the Arizona side versus what's happening on the California side? Is California side significantly better than the Arizona side, or vice versa? So you can run some statistical tests on there. So that could potentially be useful. Yes, Max.
I think so.
Yeah, that's a good question, right? So whether the speed limits are actually being obeyed or not obeyed would be another thing. Is like, if they're not even being obeyed, so maybe your collision experience, even if they're different between similar roads, maybe they're caused by something else, right? Or maybe that's the problem, that people are not even obeying it. Yes.
I guess a counter argument to that about it being about compliance with it is that say only like 10% comply with it, but with that 10%, and you get like a 10% reduction in crashes, and it would still, I guess, be worth it for the sake of it.
Yeah, I mean, you always look at the collision data, but then what I'm saying is that if you don't find any difference, that might be an enforcement issue. If you definitely find that collisions are, so here is how to approach it, right? So I'll kind of make that sort of a safety first type of argument. You look at sort of collision experience, injury fatalities type thing, and look at injuries and fatalities on similar roadways, and on similar roadways, what's happening, where you expect similar collision rate, but then you see differential. And the only thing that's different is that uniform speed limit versus not, right? And then you can look at that data over time. But if collision data tells you that they are very similar in nature, then enforcement might be an issue. But if the collision data tells you that, one is way higher than the other, then that tells you which one is a little bit better than the other. But again, you have to be very careful, is that there are no confounding factors whenever you're conducting these spot speed studies. Because, for example, you cannot compare a stretch in California with a stretch in, I don't know, maybe Kansas or whatever. Or you can't compare a stretch in Northern California, where you can see some snow-related issues with a stretch in, like, Southern Arizona, for example, right? So you can't have those types of comparisons if there are, other confounding factors. So you have to control for confounding factors as much as you can. And then one way of doing potentially, so that sort of is like a general lesson about before and after traffic engineering studies, is that try to control for as many of confounding factors as you can before you can make any determination of what's safe or what's not safe. So you've been, so, and when you control for confounding factors, you have a good counterfactual of what would have happened had that uniform speed limit did not exist. So for example, I think if you choose the same segment of I-10 that goes into Arizona, you take a certain number of miles of that versus you take the California side. And if you don't see a significant difference in geography, then yeah, in topography, then you could rely that, yeah, they should have same, type of collision patterns. And then, if the truck patterns are different or truck collision patterns are different there, then maybe you can attribute that to, and I haven't seen any studies like that, but maybe somebody needs to think about that if there is some interest in sort of changing the policy or anything like that. But by and large, it seems like most states are happy with the policy that they've adopted. They haven't there's no clamoring for change. At least I'm not that I'm aware of. But but again, these types of policies do exist. So you could apply that same idea to the Idaho stop policy, for example, right? Which I don't think California has even adopted this year. So yeah. So I think you have to kind of think about the study design a little bit more carefully there. Okay. All right. So that concludes sort of our chapter on traffic engineering studies. And I sort of concluded that chapter with, sometimes you have to design complicated studies, but the basic idea there is to control for as many confounding factors as you can as you try to establish your counterfactual of what would have happened had that policy not been in place or had that change not been applied and all of that. Okay, so I'm going to stop here actually. So we did not get to the warrants, but that's okay because we'll get to them on Tuesday. And because now we've moved the test date, I will probably move your homework due date as well, because we do have some time. So we'll get to the warrants. If you did not get a chance to review what I had provided to you last time, make sure you review it, because we are in fact going to get that done, that warrant study next week. And then we'll kind of get into the next module for this class starting next week. So I'm going to go ahead and stop here. Today is the bike night, I think. If you're into that sort of thing, farmers market, hopefully you get some chance to have fun. If you have any questions, feel free to reach out. And I will stop here. Thank you.